Hello students, and welcome to the second video of this lesson. In this video, we're going to learn how to do some really nice practice problems. It's going to be kind of quick because it's just 4 problems. You're going to have to do a lot more practice here in your homework, but for now, let's get started. So we've got some implicit functions here that we're going to be messing with, and we just want to find dy dx, okay? It's going to feel like a nice little pattern here, but you have to have your calculus differentiation rules down. All right, so let's look at our first problem. If I take that derivative 2 times y, and then I'm taking it with respect to x, so I have dy dx kind of like a little breadcrumb coming out here. Okay, so that's going to equal 2 dx dx, so I'm not even going to write that, plus 3, so the derivative of 3y is just that constant multiple 3, but I still have dy dx here. Okay, so here's what you're going to do whenever you have these problems. If you have multiple dy dx's coming out, you're going to bring all the dy dx's to one side. So I have 2y dy dx minus 3 dy dx equals 2. And then what you're going to do with that is you're going to factor out that dy dx. So dy dx times 2y minus 3 equals 2. Now you got 1 dy dx, and you just divide that group to the other side. So divide here by 2y minus 3, divide here by 2y minus 3. And we're going to get dy dx equals 2 over 2y minus 3. That's it. All right, bring all the dy dx's to one side, and then just divide it out, factor it out, and then divide, and you're all good to go. All right, so over here we've got another problem. Again, you're gonna have to know your differentiation rules, especially as we move forward in our next lesson on related rates. Okay, so 2x plus e to the y, so I'm going to take that derivative with respect to x, so I'm going to get 2 plus, okay, e to the y, that's e to the y, but I need a chain rule there. The derivative of y is 1, but with respect to x, I get another dy dx to multiply by, equals 2x minus 2y, subtract 1 from the exponent, but I've got that little breadcrumb dy dx coming up here. Okay, so whenever you're taking it with respect to a variable, you always need to have those breadcrumbs if you're not taking it of that variable, okay? So again, bring all the dy dx's to one side. So e to the y dy dx plus 2y dy dx equals 2x minus 2. Factor out the dy dx, so dy dx e to the y plus 2y equals 2x minus 2. And then divide e to the y plus 2y, e to the y plus 2y. Those divide out, and you're left with the dy dx, dun dun dun, exactly what should happen. That's what we're solving for. And we're gonna have 2x minus 2 over e to the y plus 2y. That's our final answer. Now you can substitute in values for x and y and get the slope at any point. All right. Now over here we've got another one, but what I want you guys to notice is that we actually have some multiplying going on. 2 times x times y. Okay, so if we've got a product, you need to still use the product rule. All right, so derivative of the first is going to be 2 times the second, which is just y, plus the first, which is 2x, times the second, times the derivative of y, which is dy dx, 1 dy dx, equals 6y dy dx plus 2. All right, so you're using the product rule, nothing changes, you still have to follow through with the product rule. All right, from here, it's the same thing that we've been doing on the other problems. Dy dx is to one side, divide it out. So I'm going to have 2x dy dx minus 6y dy dx equals 2 minus 2y. Okay, what can I do with that? Of course, factor out dy dx. So then I'm left with 2x minus 6y equals 2 minus 2y. Okay, what can I do with that? Let's just divide. I can see, because everything's divisible by 2, I can see I'm probably going to factor that out at some point. But let's just do this right now. So 2x minus 6y. All right, so dy dx equals, I'm going to factor out here. So 2, and then I get 1 minus y. And then down here, factor, so 2, and I get x minus 3y. All right, so then dy dx equals, because those 2's divide out, and I get 1 minus y over x minus 3y. There it is, okay? I know some of these things may not look pretty, but I've told you time and time again that calculus work may not look pretty. Well, may not look as pretty as some of your other math problems from previous courses, but honestly, that's beautiful. That right there is beautiful. And let's look at our final problem for this video. One more implicit differentiation. We're gonna get started. So 15x subtract 1, so squared, plus the constant, so 0, equals 2 dy dx minus, so I've got some tricky product rule here. So let me just, so minus 6x times y plus, nope, not plus, because it's going to be times a negative. So minus, let's see, we've got the derivative of the first times the second plus the first, so negative 3x squared, times the derivative of the second, so dy dx. Okay, perfect, I got it. All right, so what are we gonna do here next? I have the dy dx's on the right side, so I'm just gonna kind of like do it backwards and just leave dy dx on the right side of the equation, okay? So I've got 15x squared plus 6xy, because I bring this part over, equals 2 dy dx minus 3x squared dy dx. What I can do with that is I can factor out that dy dx. 2 minus 3x squared equals 15x squared plus 6xy. And then I just divide that on over. 2 minus 3x squared, 2 minus 3x squared. All right, this is looking really nice. So 15x squared plus 6xy over 2 minus 3x squared. That is going to be dy dx. And what you're going to see as we move forward here is that we're going to actually start to use these values, right? And you're going to find that this stuff is really easy to work with, because usually you're going to have a coordinate, an x and a y coordinate, like we had in our previous video, where you're able to substitute that value in and figure out the exact slope, the exact rate of change at a coordinate now. We have a couple more videos in this lesson. Of course, we've got homework for you guys to work on in this case. So really make sure that you're going through it step by step. Like I said, it kind of feels like a pattern when you're doing this. But of course, if you do have any questions, please just reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.